Uh, I get. All right. I hope you guys can hear me. This is Mahmoud Hassan, the SAT Math Tutor from my tutoring studio. So, in this video, we'll be talking about some of the hardest problems that you guys can see in your next SAT exam in the math section. Okay. So, let me just get my whiteboard. In the meantime, if you guys are joining, please enter your information, like put your name and the city you're from. I'm excited to know more about you. All right, so today is March 19th, 2025. So I'm just getting out the problems. Okay, so we're looking at these four problems here, and I'll also show you how you guys can use Desmos uh, to fast forward the process. Like sometimes you can use Desmos to solve the problems very quickly. So I will show you a manual way of solving it first, and then I'll show you how you can use Desmos to solve it quickly. Okay, so this problem statement says the function f is defined by f of x is equal to a to the power of x plus b, where a and b are constants. In the xy plane, the graph of y is equal to f of x has an x-intercept at 3, comma 0 and y-intercept at 0, comma negative 342. What is the value of a plus b? So if I look at this function, I have f of x is equal to a to the power of x plus b. And I know that my x-intercept is at 3, comma 0. So this f of x is basically y. So I can write this as y is equal to a to the power of x plus b. So I put y to be 0 and x to be 3. So I have 0 is equal to a to the power of 3 plus b. So that's my first equation. And my second equation can be formed using the y-intercept, which is at 0, comma negative 342. So I can write this as negative 342 is equal to a to the power of 0 plus b. This is my second equation. Now, from this second equation, I can find the value of b. Let's see how. So a to the power of 0 is basically 1. Anything to the power of 0 is always 1, so keep that in mind. And that's coming from exponent properties. So 1 plus b is equal to negative 342. So if I subtract 1, I get negative 343 for b. So I just found my value of b. So let's try to plug that in this first equation and solve the value of a here. So I have 0 is equal to a to the power of 3 plus b. So instead of b, I can put this as negative 343. So it's 0 is equal to a to the power of 3 minus 343. Add 343 to both sides. I get 343 is equal to a to the power of 3. And when I take cube root, I get 7 for a. So a is equal to 7 and b is equal to negative 343. I need to find the value of a plus b. So a is 7 plus b is negative 343. If I add them up, I'm getting negative 336. So this is how we solve this problem. Now let me just show you how you can use DESMOS here pretty quickly. So I know that my f of x function is f of x is equal to a to the power of x plus b. And I just put my first condition, which is f of x to be 0 is equal to a to the power of 3 plus b. And the second equation is negative 342 is equal to a to the power of 0 plus b. Now, I see that I have two equations with two variables. What you can simply do is just replace this with x and y. Replace this with x and y. Let's see if we find the meeting points here. So exactly, you can see that these two lines are meeting exactly here, which is 7, comma negative 343, which means x is 7 and y is negative 343. And your original x was basically a, and original b is basically y. And this is how you can solve this problem pretty quickly. I have a plus b, that's negative 336. This is how you can use DESMOS pretty quickly in this problem. I hope this makes sense. Let me know how much you have understood this process, or if you have anything to share, let me know in the comment section. Also, let me know how much you like this process of solving the problem using DESMOS. Perfect. Now let's move on to the next problem. The second problem statement says 684 is p% greater than 9. What is the value of p? So let's see. We have 684 is means equal, p% greater than 9. So how do we actually translate this information? This is very important. Anything in its original form is always gonna be 100%. Remember, in the percentage, anything in its original base form is always 100%. If you are adding something, adding some percentage, we add that on top of 100. So here it says p% greater than 9. So it would be 100 plus p%. And then we multiply this with 9. So this greater than is coming in the form of 100 plus p. So p% greater than means 100 plus p. P% less than means 100 minus p. Keep that strategy in mind. Now, this is my base value, which is 9. And now from this equation, we just solve the value of p. So let's see how we can solve it. Here, we divide both sides by 9. And if we use DESMOS here, we have 684 divided by 9, we get 76. So 76 is equal to 100 plus p%. And any percentage is basically that value divided by 100. So now we just need to solve for p here. Uh, we can multiply both sides by 100. We get 7600. This 100 from the top and bottom will cancel out, is equal to 100 plus p. Subtract 100 from both sides. We get 7500 is equal to p. So that's our answer. P is equal to 7500. Now, let me just show you how you can solve it using DESMOS. So, you know that it's 684 is equal to 100 plus p% of 9. Now, this p cannot be evaluated if it's in the form of p. So I'll just write this as x. And let's just see. We are getting 7500. Perfect. Let me know how much you have understood this process. And if you have any questions, let me know in the comment section. All right. Now let's move on to our third problem. Let's see what it is talking about. Two numbers a and b are each greater than 0, and the fifth root of a is equal to the cube root of b. For what value of x is a to the power of 8x minus 4 equal to b? So let's try to write down the information here. We know that a and b are both greater than 0. So a is greater than 0. B is also greater than 0. The fifth root of a, which means a with a fifth root like this, is equal to the cube root. So we write it like this. This is the cube root of b. Now we can also write it as a power in the power form. So we can write this as a to the power of 1 over 5. So remember, any root can be written as an exponent having that root in the denominator. So a has a power of 1 and b has a power of 1, but this root will just come out as a denominator. Or will it this root 3 will come out in the denominator. Okay, so this 5 will come out in the denominator. So it's a to the power of 1 over 5 is equal to b to the power of 1 over 3. So this is how you just write the same equation. Now it says for what value of x is a to the power of 8x minus 4 is equal to b. So we just need to write these as a to the power of 8x minus 4 is equal to b. Now we see that a to the power of 1 over 5 is equal to b to the power of 1 over 3. And if we just have these, a to the power of 8x minus 4 is equal to b. This b has a power of 1. So we can compare these two equations. These two equations are basically the same equations. Keep that in mind. We are just comparing. A to the power of 1 over 5 is equal to b to the power of 1 over 3. Now we are saying, hey, we just need to change the power. So if you just change the power, what can you multiply with equation 1 here with this b to the power of 1 over 3 to make it 1? If you just see closely, I can actually take, so I can just multiply this 1 over 3 with 3. So 1 over 3 times 3 will just give me 1. So for any equation, you do it in the on both sides. So I'm just taking a cube on a cube exponent on both sides. So when I'm doing that, this equation 1 is turning into a to the power of 3 over 5 is equal to b to the power of 1. And we can compare this with equation 2. A to the power of 8x minus 4 is equal to b to the power of 1. So I can write this as a to the power of 3 over 5 is equal to a to the power of 8x minus 4. Just set these two exponents equal to each other. I have 8x minus 4 is equal to 3 over 5. We can just put it in the DESMOS and solve it. So 8x minus 4 is equal to 3 over 5. I'm getting 0.575. So 0.575, I can just write this as a fraction, which is 23 over 40. So x is 23 over 40 or 0.575. Both are correct. Perfect. Now, let me just show you how you can use DESMOS for the whole problem. So we know that a to the power of 8x minus 4 is equal to b to the power of 1. And we also know that a to the power of 1 over 5 is equal to b to the power of 1 over 3. Now, let me just see if this process works. So I'll just do a trial and error process. 8x minus 4 over 1 over 5 is equal to 1 over 1 over 3. Yeah, so this process works. So the process here is we can just write these two equations and then we can just set up a proportion equation. We can just divide this 8x minus 4 by the power of this a, which is 1 over 5. And we can just write this power of b, which is 1, over the power of 1 over 3. And this proportion equation can be solved, and we get x to be equal to 0.4575. This is how quickly you can use DESMOS to get this answer. Let me know if that makes sense. If you have any questions, let me know in the comment section. Let's move on to the next problem. For the given system of equations, what is the value of 7 times j minus k? So if you look at these two equations, we see that we have j minus k minus 16 times m plus l is equal to 689, and j minus k plus 12 times m plus l is equal to 1235. So I need to find 7 times of j minus k. What we can do is we can just uh, make these terms same, the coefficients of these terms equal to each other, and then cancel them out. So to do that, I can just multiply this equation by 12, and I multiply this equation by 16. So if I do that, I'm getting 12 times j minus k minus 16 times 12 is 192 m plus L is equal to 689 times 12. So 689 times 12, we are getting 8,268. Then we get to the second equation, 16 times j minus k plus 12 times 16 is 192 times m plus L. 12, 235 times 16, we are getting 19,760. Now, if you just add them, these two terms will cancel out. 12 plus 16 is 28 times j minus k is equal to, so remember, we are adding these two equations because these two signs are different. If we subtract, these will not cancel out. So keep that strategy in mind. So if we add these two values, 8,268 plus 19,760, it's 28,028. Now remember the trick here. We need to find the value of 7 times j minus k. So in order to get 7, I need to divide this 28 by 4. So this will just come out to be 7 times j minus k, and 28,028 divided by 4, we are getting 7,007. So that's our answer. Now, to do it very quickly in Desmos, what I'll do is usually I'll just take these to be x, and I'll just take these to be y. And I just need to find the value of x here, 7 times x. So basically, I need to find the value of 7x. So I'll just set up this proportion equation over here. So I have 7. So if you just look at these two equations, I have x minus 16 times y is equal to 689. So instead of j minus k and m plus L, I'll just take these as x and y. And the second equation is x plus 12 times y is equal to 1235. Simply get the value of x here. We are getting 1001, 19.5. I just need to find the value of x. So x is 1001. I just need to find 7x, which is 7 times 1001. That is 7,007. That's how quickly you can get the answer. I hope this makes sense. If you have any questions, let me know in the comment section. And please like, share, and subscribe to this channel. And I'll see you next Wednesday at 12 p.m. Eastern time, same channel. And I'll come up with some awesome problems for you. Let's crush this SAT exam, and I'll see you in the next video. Now, let's get to study.